Hello, everyone. Hello, and welcome to the AWS OnAir Data Dive. I'm your host, Jason Hunter, Principal Solution Architect at DynamoDB. I'm here with a couple of guests. I'll introduce them in a second. About 2 months ago was the last time I hosted the show, and at that time, we had a guest from OpenSearch on, and we talked about ways that OpenSearch can drive, at the time, it was like a shoe store, and we learned how to do text-based search and how to do more semantic search and how to do RAG, the retrieval augmented generation. And it was so popular that I thought, hey, let's bring on a couple more OpenSearch people and talk about something else. So now, instead of talking about how do you use search to drive a front-end store or search-centric application, this is how do you understand what's going on in the back end using OpenSearch for observability to say, all right, like if I have an error, why? What are my metrics? If a customer calls in and says, I couldn't add something to my shopping cart, how do I figure out why not? And so that's the topic of today, observing what's going on in the back end. It's amazing that OpenSearch can do the front end and the back end both to me. So I'm here first. I'll say hi to Jag. Jag, you have the best backdrop ever. That is not a Zoom backdrop.
That is not.
That's crazy. So please introduce yourself.
Yeah, I'm Jagdish Kumar. I go by Jag, and I'm a senior solutions architect with the OpenSearch SA team based out of Austin, Texas. Nice to be here.
And then we also have Josh, who got no budget for his background at all. Jag, can you give him a plant or something just to...
Okay.
Right. I've got the leadership principle of frugality flowing everywhere around me.
So Josh, please introduce yourself.
Hey everyone, my name is Joshua Bright. I am Senior Product Manager within the OpenSearch Service team.
All right. Let me give you the first question, Josh. Just what is OpenSearch?
Yeah, absolutely. OpenSearch is an Apache 2 open source search engine for all intents and purposes. And what customers love when they think about OpenSearch is how quickly it returns results. So you grab a series of documents, OpenSearch looks at it, evaluates it, indexes it, and boom, you've got really, really quick results based on the documents that you fed into it or ingested into it.
Right. It's like there's a code base that's open source, but there's also a service, right?
Exactly. Yep. So there is the Amazon OpenSearch Service is based on the OpenSearch project, which is the open source project. So things happen in the open source. We have an entire community where we collaborate, and what happens in the open source ultimately manifests itself onto the service.
Cool. And so, like I said, 2 months ago, we learned how to use it for search. I type in Nike Air Force One, I get a lexical match. I can type in evening wear, appropriate stilettos or something. It'll give me something where that was semantic. We're used to that. Today we're talking observability. So can you give us a briefing on about observability?
Yeah, absolutely. Yeah, so that search principle is absolutely crucial in observability, because observability is all about taking the insights from your systems, your applications, your infrastructure, and being able to develop like a hypothesis of when something goes wrong. Fortunately, hopefully that doesn't happen. But when something goes wrong, you could take these insights and perform an analysis on them. So some of the pillars or insights can manifest themselves as logs. Logs are things that are emitted from your applications, your services, and your infrastructure. You can aggregate those logs into metrics. So let's just say, as an example, a web server is throwing 500 errors. I can perform an aggregate on those logs and count like how many 500 errors were thrown over time, and build out like a nice graph and dashboard to review for the services that I'm responsible for. And the last piece that's more and more popular, but it's a little bit more difficult to implement, are traces, which I can take my logs and I can see as people move through or systems move through a given workflow, I can trace where that workflow or the individual or the system is moving through the different services to accomplish their task or fail. Sometimes, right? Sometimes failure is the hot topic that we have to jump into.
We're all used to logs. Been doing logs for decades. Tracing is kind of new, but it sounds very interesting because without tracing, I would go to my logs and try to do timestamp based, like around this time and around this time. But I wouldn't know that what's going on here is related to what's going on there, except for a timestamp correlation. If I've got 1,000 requests a second, good luck to me, right? So it's somehow you kind of say, this is request ID 123, and everybody remembers and can output this is related to request ID 123. And OpenSearch comes in and is able to give you that view of that, so that now I can see, all right, here's the request life as it touched all the various services on the back end, right?
Yeah, exactly. So OpenSearch, I think Jag is going to get to this in just a moment, but OpenSearch has a solution where you can very easily analyze your logs, view dashboards for your metrics, and then see what is the pattern, what does that workflow look like for an individual as they're looking through their store or favorite e-commerce site.
Right. All right. So to you, Jag, then, how would I go from an application which today maybe does some debug statements and actually add suitable output so that something like OpenSearch can process it? That sounds hard.
It is, which is why, there are standards that are now in place that can make things easier, right? Instead of us building a lot of code that would have to go and instrument all these different microservice applications, we now have the OpenTelemetry standard, which is OTel, where it's not a single thing. It's a collection of say standards, tools, SDKs, and APIs that allows you to, in an open source way, able to, if you have a Java code, for example, you can just install some SDKs, make the code auto-instrument itself by importing these libraries and SDKs in your code. And the OpenTelemetry standards is now able to emit these telemetry data in standardized format where you have your logs, your traces, and metrics that you can now collect. The goal is to instrument once and, read multiple times in different forms, right? So OpenTelemetry standard makes it a lot easier where, you have these SDKs that you can install in your code. There are 11 languages that are supported, Java being the most popular, but every language you have libraries that comes in and you can instrument your code, get these data out, which at that point, now that your instrumentation is made easier, you have something called a collector component, right? So where you have OpenTelemetry, OTel compatible collectors that understand these OpenTelemetry standard data coming in, and they are, again, open source, right? So we can get the data in, you have an exporter component, you can transform the data a little bit if you want to, and send it to a backend service like OpenSearch that natively understands these OpenTelemetry data and can do a lot of things, cool stuff for you, like right off the bat.
Okay, so it's not an open search thing. It's got an open standard, right? Where people who make services said, let's agree, we'll figure out how to output the data, how to collect the data, transform the data, and then you have a pluggable backend that could be a variety of things, but OpenSearch says, well, there's a standard way to get logs and metrics and
and
traces, and we'll process it over here.
Yeah, and the cool thing, right? Like, so now that, let's say you change your backend from, let's say, a less popular backend to something like OpenSearch, for example, right? Where observability is like, there are a lot of plugins that supports it. If you're using a collector, you don't have to strip the entire setup. All you have to do is go to the exporter, switch the backend, and you still are collecting in open standards, and the backend now still supports it. That's the beauty of bringing in that standardization so that it's tool agnostic at the same time adheres you to standards while making things easier for you.
Right. I think we need a demo. It's been fun talking about it, but let's see it.
Yeah, sounds cool, but let's do a demo, right? I got you. So
let's see what this is like. All right. Oh, shoe store.
Let's start there. So before I start shoe store demo, we spoke hotel, we spoke OpenTelemetry. So Jason, what do you got for Ollie? What do you got for Ollie?
Ollie?
Yeah.
It's a good friend of mine. Known him a long time. Ollie. Who's Ollie?
Or O11Y?
O11Y Ollie. This is like I-18N internationalization, L10N localization. It's O11 characters Y.
Y. There you go. So yeah, so Ollie
observability, isn't
it? You nailed it.
It's observability. Yeah.
It is.
Right, so I got you.
Yeah. So Ollie, we are going to demo the Ollie stuff in OpenSearch. So let's do observability. So I'm showing you an OpenSearch dashboards. That's kind of the visualization tool we have to visualize the data. We have a bunch of plugins on the left, right? So one of the plugins we have is observability, and plugins, the plugin is like a set of code that's pre-installed. So the traces and metrics that are being emitted to OpenSearch, it can already understand the data that's coming in, and it can pre-build a lot of things for you without you having to do a lot of work on the back end. Yeah.
Very good. Very good.
Yeah. So taking the shoe store example, right? So let's say we have a e-commerce store selling shoes and much more. You have a bunch of microservices application that's running in Kubernetes pods, all talking to each other. Let's say you do a checkout of your favorite shoes, some tracing happens behind the scenes. All that activity is being sent to OpenSearch. We collect that data. We have mechanism to ingest that data. OpenSearch ingestion is a great tool, which is a last mile delivery tool that can allow you to, safely and securely at scale deliver the data to OpenSearch. So you have the data coming in, and if I go into the observability plugin, I have the ability to create a abstract application that can read the incoming data, and as you can see, it already can start putting together the different service maps that's happening, right? So, for example, if I am doing an application off the bat, I would just say this is going to be an e-commerce store, and I would have to go to the log source and say what's the index that I'm going to work on, and do some service maps, which it already natively understands, and then encapsulate that into the application, which is how I have this shoe store. Let me change the dates a little bit. 40 years ago. I don't want that.
You're early on the internet.
We're going way back.
Yeah. So let's do 40 hours, right? So
that's better.
Now we got neatly put together. This is all pre-built code, by the way, nothing that I built, right? So this is all part of the observability plugin. You have these different services that comes in. It's already tracking that. And then you have a nice visual composition map that shows you with some color grading, like how these different services talk to each other, right? What kind of...
You make the font bigger?
I can definitely make the font bigger.
Yeah, a little bit. Yeah, a little bit in the graph. Okay, so to try to read this, put on the reading glasses. Front-end client, authentication, recommendation, inventory. We have order, payment, database. You understand, because of the data that came in OTel, how all my microservices fit together. You just figured that out from the traces, I assume, because it's A goes to B goes to C. You've got purple, where more purple means slower. I want lighter. that tells me where the time is spent. So the payment was fast, or it took time. Although I think we're going to, from your metrics, I saw why payment was fast. 100% failure. Look at errors for me. Show me errors in the position map.
Exactly.
See your errors.
There you go. So
payment's the problem.
Exactly.
100%.
Yeah.
Why has revenue gone down, Jag?
Now you know, Jason. Now you know exactly why people are checking out, and you're not getting money.
Something's going wrong with payment. This is a good way to annoy your customers. They were ready. And all right. So what do I do about the fact that payment is a problem?
Yeah. So you can visually see that payment is a problem, but we can also confirm and drill down a little deeper, right? So if I go to the services, I already have some derived metrics from the trace groups that came in that tells me good information about what's the latency, number of requests that's coming in, what's the error rate. And that's a good metric, right? Because we know payment is an issue, and we see that payment is having 100% error rate. So something's really terribly going wrong. And I can
click the 8, man. Click the 8. Yeah.
So I can click on the traces to drill down further, right? So now my filter is only on the payment service, and all the traces from those trace groups are being filtered. And I can choose one of these traces, right? And kind of walk down, and I can see there is some latency. There is a chart that walks me through what's the time spent through the different layers. And you can also see the individual spans that the request propagated through as part of the trace, right? So you want to read this, Jason? Kind of see where...
Yeah, well, you had a trace ID up top, so that's how I know that all these different services are related. They're a big number that indicates this. Started with a front-end client checkout at 0 milliseconds, and that took till 30, and so it calls the one below it. Front-end client got a post. Payment checkout got a post. It's colored red with an error. That seems to have gone wrong. There was inside a payment HTTP post, which was a red error, and after that, some green stuff, which I guess was logging, saying like, hey, that didn't take too long, but the problem seems to be the payment checkout, payment post.
Exactly. So
you got some nerd underneath that. Does that tell me anything?
Yeah. So this, you can actually drill down to the actual payload and get some more information about these traces, right? And like, which now already is very powerful enough, right? We just did OpenTelemetry standard, got the data in. With few clicks, we already know like kind of which method or kind of API we have to go and focus on. And now let's maybe drill down a little further. And we'll go to, we'll see how we can correlate this information, because ultimately that's the goal, right? Disjoint, sorry, why do I keep getting this? Okay. There you go. All right, so I got that
trace ID from the previous one. Okay.
Exactly.
You surreptitiously copied it. All right.
Yeah, copied it. Now I'm able to go and explore the logs, because instead of being a disjoint set of information, now I'm able to go from the trace ID and go to the actual log that has some issues that gives some good information that allows me to go and take care of my system. So in this case, I go in and I filter, and so we have a file 3. So that would, in this case, mean talk to your payment service team and figure the error out.
Right. We called out, they said no, 503 error response. Now it's time for us to call them and say, hey, why when we call you to process a credit card, do you say no?
Yep.
Do you suppose they're using OpenSearch Observability?
I hope so. That would speed things up.
Maybe you need to tell them the request ID you made. Okay, good. Someone's asking a question here. How does Amazon OpenSearch Service integrate with other AWS services to enhance observability integrations?
Yeah. So Amazon OpenSearch, like we see, we have the native integration to get the data in, but also there are integrations with other services like DynamoDB, DocumentDB, and S3, which is one of the features we'll talk today, which allows native integration to those services. We have OpenSearch Ingestion, which is a serverless ingestion pipeline, last mile delivery, like I said, that is streamlined to get these observability data, regardless of how you collect it. You can post it to OpenSearch Ingestion. It can deliver the data for you. You can do similarly for CloudWatch logs. You can get integration with your Kinesis Firehose. So it is well integrated with a suite of services so that you're, there is observability if you get trace data in, but if you don't have trace data, you still can ingest logs from all these integrated services at scale and really, really quickly.
All right.
I think the other thing that I would add is that the beauty of ingestion service is it's a serverless service, so it scales up and it scales down. So when you're having like peak traffic, like it'll scale up automatically for you, and then when things start to level out, then it'll scale back down. It's really a really handy service.
As a DynamoDB specialist, I appreciate serverless.
There you go.
Pioneers.
Pioneers. Is there a way can we dig into the log stuff?
Yeah. So let me share. Okay, you're seeing my demo, right? So the logs, the language that we use to explore the logs, the predominant one that we use is called PPL. You want to take a shot at it? What that means?
Princess Powered LangChain.
Close. So it's Python processing language, right? So we have
sure.
So you have PPL. It's kind of very, like Linux, right? So you have data. It's a way to go query a source, in this case, a source index, and then pipe that data through multiple stages where you can do transformations, aggregations, group bys, filtering, kind of like pipe language we'll use in like any Linux areas, right? So
I knew PPL and didn't know I knew it because it's just what Unix does.
Yep.
Okay.
All right. So what I wanted to show you is you can go write PPL. So I have this events logs explorer. So I'm going to go get the logs data here, for example, right? And I can do a basic PPL query where I'm going to just query the data and sample it so that I get 5 records, right? Very simple, straightforward query.
All right. Oh yeah, there's your pipe head 5. Hey, it is you. Okay.
Yeah, but a lot of times it's not that straightforward. We need some more complex queries, but if we are new to the PPL realm, I got something cool for you. I want to show you.
I see it right there.
Yeah.
Between the PPL query and the text, ask a natural language question to generate a query. I don't actually have to learn PPL.
No, you don't. You can use the assistant and the Ollie assistant, and the assistant will teach.
Name Ollie?
Yeah.
The little box name is Ollie here. I like that. I don't know if that's true or not. That's great though. All right, give me the last error logs for the last couple days. Like how many errors did I get today, yesterday?
Okay. So let's ask how many error logs. Let me remove the typo. Although it will not worry about that.
Yeah, that'd be an open question. Like, how many people fix their typos when they're typing into a chatbot? It's like, yeah, it knows. It's like,
yeah.
How many?
Yeah. So right now, what I did is I just
in the last 2 days.
Yeah.
Okay.
Yeah. So I just generated the query. I didn't run it. So now,
no, I thought you had no errors.
yeah, no, so there is an option to, generate as well as generate and run together.
Okay.
I just wanted to show you how to generate. The next one, we can just run it directly. Go for it. Give me another one.
We saw a 503 response code. Can we see like the response codes I'm getting or something like that?
Yeah. So let's try. So how many requests? There. I do it. Sorry. Group by response code last 2 weeks, maybe.
This can also like help you learn PPL as well.
Yeah.
So it's not just 100% I'm typing in these questions, but I could become more of an expert in PPL and just go dive into PPL in the future.
What's cool is I can tell that this AI system knows the schema, right? I'm thinking like, why don't I just go to my favorite chatbot and type this in? But the thing is, it doesn't know anything about my schema and my columns, right? So it's aware of your columns, and somehow it knows what they mean, which is pretty. Or if I changed my column names to be like XYZ, I wonder if it could do it. But it's able to figure out what a response code is.
Yeah.
Right? By response. So it knows that response is a code.
Yeah. You can do some basic visualizations and play some charts if you need to, right? It's all right there. It makes it easier. Like you said, it's aware of the source data you're querying on. So it's, index aware, builds the right PPL. And like Joshua mentioned, it's a great tool to learn PPL as well. Right. And this is where I would switch the indexes. So let's say, now I switch to the sample flight data that I have. I can see that these are some of the fields that I have. So now that I drill down, it's already aware of this index. And maybe let's do a query here. You got something? I'm gonna try.
I'm flying out LAX. What are the odds I'm getting delayed? How often are flights delayed more than 30 minutes? Because I got a 45-minute layover. Trip tells me be careful. Yeah.
It's made it from LAX.
I like to waste time.
Let's see.
Yeah,
more than
or something.
All right. Let's give it a shot.
If this works. It did work.
It did.
Where origin equals Los Angeles. And flight delays and count. Oh, there it is. 3. Only 3?
Yeah.
This is fake data. This is fake data. No way. There's no way.
It was a good day.
Yeah.
Someone says, how does it look when the query generation fails? That would have been a great... Imagine if it had just failed and you'd be like, well, in advance. Type in something like, what's the weather right now? Tell me.
Yeah.
Like, let's...
What's the weather?
You always wonder what these systems do in that situation. My gosh, did it actually say sunny? Because it's an airport. Whoa. All right, I need a different bad one. What's 5 + 2? I don't know, something that it won't... I might even figure that out.
Yeah, so
Josh, what's a bad question that I won't be able to do?
How do I make... What's a recipe? What's a good recipe?
There you go.
What's a good recipe?
That's in the airport data. I'll be impressed.
What's a good recipe for what?
Yeah.
Cookies.
Okay.
Cookies.
Good.
Bologna. I don't know.
Bologna.
It's gonna help you out whether you try to or not.
Yeah.
First of all, I just want to be clear. I am not into bologna cookies.
Bologna cookies are the best. All right. At this point, we have a survey. If you're enjoying the show as much as I am right now, fill out the survey. We'll post a link in the comments here. If you have your own questions, post them in the comments, and we'll get them to pop up here. Does it have a free trial? Is the question.
Yeah. So if you are using the 2.13 latest version of OpenSearch Managed Service, then you can try this as part of your code. It's available. It will ask you while you spin up your cluster that if you want to enable the natural language query processing, you just check the default and it's available for you.
And I think I've been asking Jag too many questions because he has the best background. But Josh, you look like you need a question. So let me throw one your way. As we look at processing these logs, I'm used to services that generate tons of requests, and I tend to put my data into S3 because it can be huge. So does this change it where I have to always load the data in OpenSearch, and am I going to be thinking about terabytes, petabytes of data in OpenSearch, or is there anything I can do that keeps my logs and traces and everything in S3?
Yeah, that's a very common occurrence, actually, where when we talk to customers, they say that, especially like the verbose logs, like VPC flow logs or WAF logs, that sometimes they run into scale or cost concerns of adding that all into OpenSearch. And so, yeah, actually back in May, we launched a new integration with S3. It's zero ETL integration with S3, which will allow us within OpenSearch to kind of extend the view outside of just OpenSearch indexes. So what we end up doing is we create a direct link or pipe with S3, and to reflect what exists on the other side of that pipe, we use glue data catalog tables, because so the table itself will help reflect what the schema is on S3. So as an example, VPC flow logs, you've got source, destination, packets, size,
big,
kind of stuff, right?
Big.
We're talking huge.
Right.
So,
yeah, but awesome, because if something goes wrong, you can go figure out exactly where, this. But
exactly.
I don't know that in OpenSearch, probably.
Right. Well, so here's kind of the dilemma that you've got, right? So if you want near real-time analysis of those VPC logs, OpenSearch is still the place to go, because that's where you get full text search, and it's very, very quick. So by doing that, you can, because it's within the index, you're able to unlock additional kind of functionality that OpenSearch offers, like dashboards and etc. Now, with this integration with S3, this is actually more on the side of infrequently queried logs, because what we do in the background is we have a serverless instance that will go and query the logs, after you set up the implementation. It'll query the logs for you, and you're charged you're charged for the compute that's used to query those logs at the time, which is because the serverless, it spins up as well as spins down. But because you're querying, you're paying for the compute when you're querying. If you were to query a lot, then it just doesn't make sense. It would be too expensive comparatively to just fully ingesting it into OpenSearch.
Yeah.
So,
if you're going to do a lot of interaction, load it in your search system and
exactly.
Interact. But if it's like VPC flow logs, I'm going to once in a while go spelunking for something went wrong, and I want to go pull, I can go use OpenSearch to do that. That's what I'm hearing. So,
absolutely,
hottest tier, the coldest tier kind of thing, right?
Exactly. Yeah. So you've got different options for your data strategy. If you want near real-time analysis, then you can fully ingest that into OpenSearch. If you want access to these infrequently queried logs that you would normally have to jump over to another tool or create kind of a one-off ingestion pipeline for like historical or compliance analysis, then the zero ETL integration, that's where it really sings.
What kind of data could I have in S3 that I'm going to query against? VPC flow logs you mentioned. Anything else?
I mean, anything that can be represented in a table. we'll have to be able, unstructured logs are still a better fit for OpenSearch's hot index because it unlocks the full text search. In this case, because we need a table to represent what that data looks like on S3, it has to be, reasonably structured. So for those who have, as an example, for those who have like really nasty nested JSON, you'll have to unpack that JSON either at query time using PPL or SQL, or expand that view and explode the table when you're creating the table to represent the data. Hopefully that makes sense.
I just got stuck on nasty JSON.
JSON. No, I assure you, you were not nasty. You were wonderful.
But I am nested, whatever that means. So, did you just invent Athena? I mean, did you just invent Athena? Is that what you did? Like, is there? Why do I need you? Why do I need OpenSearch?
What I've described to you is, first of all, hats off to Athena. Great tool.
Okay.
No doubt about it. The difference what I've described thus far is a direct query out to S3, and that's what Athena does. The difference that we've added is, as I mentioned at the very beginning, OpenSearch is an indexing engine, right? So we thought, well, if we have a table, like to represent the data on S3, we could utilize that table as a way to accelerate data, right? If it's a standard table, we could apply a skipping index to help out with querying. We can create a materialized view on that table. So these are, or a covering index if we wanted to ingest the data into OpenSearch. So we thought, like, let's experiment with this, and it works really well. So the difference between us and Athena at its core is we offer the ability to accelerate your data on S3 and provide an easy way for you to get the information into OpenSearch, where you can, if you so chose, you could build out dashboards on your data in S3 by creating a materialized view. You could do a just-in-time analysis of your data using a covering index by indexing it in to OpenSearch. So we've got a number of different options. Obviously, because this is infrequently queried logs, you want to be mindful of just how much you pull into OpenSearch. But yeah, we've seen some really cool results and some really cool dashboards. I think Jag.
I think we're going to soon. Jag looks like he's ready to start clicking. So what I'm hearing is, like, I mean, we've used Athena. You hit the button, it brute forces it. You hit the button, it brute forces it again. You could brute force it, but you could also say, I've seen some things and I remember some things. I know where things are. And also maybe even materialized view. I can remember deeply. Like I can remember light things. I can remember deep things about what's in S3. Not load it all, but remember some things to make it faster. So it's,
exactly. You could use it as a scent. You could ingest what you need, what the scent that you needed to allow you to go and perform a more thorough analysis, later. So you can build out an aggregation for your dashboard, which will allow you to be like, okay, here's where the problem is. Now I want to go in deeper and use and directly query that data. All from within OpenSearch. You don't have to move.
Let's prove it. Let's prove it. Jag, back to you.
Yep.
I want to see speed.
I have the honors. Sounds good. So again, back to the OpenSearch dashboard. So we have like something called a query bench, right? I'm going to operate from here primarily for this demo. But like Joshua mentioned, like there are operational logs like VPC logs or your VAF logs or database logs. Sometimes you want them to reside in S3. Maybe you may want to accelerate a little bit and index in OpenSearch, but majority of the times, maybe you just need it there, right? So in this specific demo, what I have is I have enabled VPC flow logs for my account.
Okay.
So there are networking activities that's being tracked. There is a specific format that it's already generated. The schema is well known. So what I have done is I created a external source similar to Athena, right? There you're pointing to an S3 location and able to access the Glue data catalog, where kind of allows you to tag on to specific schemas if you have already defined it. Or you can also create a table from right within your OpenSearch query workbench and import that schema on the data, right? So which is exactly what I'm going to do.
Okay.
So I'm going to, this is going to be really live. So let's see. All right. So I got a table that I'm going to create. So these columns, I know it's the default schema that VPC flow logs come with. It's pointed to this S3 location where I have the logs funneling in, and it's using Fargate, right? So I'm going to go in and...
So, your schema is somewhere like in the VPC flow logs. This is a good schema to use. It's not where all the columns are. Make the table.
Yeah.
All right.
Yeah.
What's it doing now?
Yeah. So OpenSearch is taking your queries and it's using some compute to go back, validate the location, validate the schema, make sure that what you have defined and what it's identifying through the catalog, it's all valid. Like you cannot just put some random things and OpenSearch cannot, okay, that's good, let's go, right? So there are validations that happen. So it does some checks on it, makes sure it's creating the table, make sure it's available for you to query. And finally, once all those checks are done, it gives you the symbol, okay, now we have a table, let's go for it.
Right? It says no result, a very fun response. No result. Like, well, okay, I guess no result's a good result.
No result is a good result. Exactly.
So, I think it's also worth mentioning that the tables that we create here, I mentioned Glue Data Catalog, that's where the tables ultimately are stored. So you use OpenSearch Services Query Workbench to manage the tables, create tables, drop tables, etc. It's all done within OpenSearch. You don't use Glue Data Catalog at all. That's just the holdings slot.
Yep.
So just a point of clarity there.
Thanks.
Question on latency from S3. Reduced latency, we didn't see it. I mean, we don't know where the latency is high. S3 is pretty low latency always. It's not like Dynamo, but
yeah.
So the latency though, like
I'd say, right?
Exactly. So I think the latency that you observed in the demo is the result of, it's a serverless compute instance that we spin up in the background. So the beauty, like I mentioned with the ingestion service, the beauty of serverless is it spins up when you need it, and then it spins down when you don't need it. The thing about serverless though is it does have that spin up time, and so that's why you saw some latency when Jag kicked off that query.
Gotcha. On demand allocation of compute. It saw your definition. It verified it. Now we're in the catalog. Let's do a query.
Yeah. So I'm going to do a simple query, right? So we all know SQL. So it's just doing a 3-point notation on the table. At this point, I'm not doing any acceleration, right? This is pure S3 data. I'm directly querying from within OpenSearch. No kind of acceleration done. Let's see. And this is the very first time we created the table. So there are, on top of the serverless compute being spun in, we also need the optimizer to understand, right? So there are new tables and it needs to go figure those things out. So there is that initial overhead that adds to querying the data. So let's just give a.
This is Athena with a pretty UI. Is that right?
And more.
You want to say yes. You want to say yes.
Athena it's a great tool, right? Like Joshua mentioned, it's Athena with a good UI so far because we are exploring the data. We are doing schema on read. We created a table. We just queried it. Nothing came into OpenSearch, right? But there are ways to accelerate it, like Joshua
mentioned. Is it the accelerate button?
You betcha. It is. So
I'm the host.
I think it is worth mentioning that we are using Query Workbench for this view, but you can also execute these queries at Discover, right? So that's kind of the other place where more of like the analyst persona would go and query from. This is like the cool spot to go to where you're doing kind of the admin stuff of creating tables and creating these wonderful accelerations that Jack's going to show up.
Yep. Yeah. So this UI, so I have 3 acceleration patterns, right? So to quickly walk through, skipping index kind of brings in metadata of your data in S3. So it creates either Bloom filters or min-max of your columns, make sure it intelligently is able to scan data in S3 by using this information on the columns in index.
And scans the files that might have the answer.
Correct.
So it remembers metadata about what's in each file, in the parquet file. And so if you have a date or something, it can find it by date. If you have what else? Like a color, it can know like, oh, that color doesn't appear in this file. I don't even have to open up the file. So we read way fewer files, right?
Right. Exactly. So that's the ultimate goal, is how intelligently we can scan as less as possible, skip files we don't need to, and skipping index allows you to get that optimization in. Covering index is a different kind of a acceleration where you may want to have specific columns that you want to index within OpenSearch so that it can power your dashboard while also tagging on to data that's not in OpenSearch and intelligently able to connect these dots together through the optimizer. So that's covering index. And materialized views are materialized views, right? So we aggregate the data, bring the aggregated data in OpenSearch, and use that for any kind of queries or visualizations. So the first one, I'm going to do skipping index. I have to give a checkpoint location to make sure this is happy. So I'm going to say checkpoint, AWS OnAir, skipping it, just to make sure it's unique.
Just to make sure it's unique, right?
So there could be a bunch of checkpoints going on, right? You can have multiple acceleration patterns. So we want to have the right location for each of your acceleration index that you have. So I can ask OpenSearch to generate it. So it can go look at the schema and say, hey, this is a min-max method for this specific field, or I want to use a Bloom filter, can use a partition, whatever that is optimal for that specific field. So you can do that.
I'm an indexing nerd. Like min-max says, well, in this file, it's between 50 and 100. So if you want something outside that, don't have to open in this file. Yep. Bloom filter is a good way to know, like, is this value in there? And it can say, not necessarily that it is, but it can often say, oh, it's not. And so if you know it's not in there, don't open it, right?
Yep, exactly.
Yeah. Love indexing.
Right. So I can...
I'm on Dynamo.
Yeah, so I can generate that. It's going to create that SQL for me, or I can just run it through the Explorer, which is what I'm going to do. So I'm going to take in my SQL, and I'm going to run it in here, right? So it's the exact same query.
Oh, okay.
It's creating these Bloom filters and value sets for few columns, not the entire ones that I wanted to. So I'm going to run it.
It'll take some time, right?
Yeah. And the very first time we run it, it's also has to do a lot of it's a job behind the scenes once you have the acceleration pattern defined, right? So it has to scan and bring in data, create that check that checkpoint, make sure it's up to date, it has all the data. So it's a job that will, like you see, there is a refresh interval. It's going to refresh every 15 minutes or so.
That's awesome. So it stays current. It's not like a one and done.
Yeah.
It'll be able to patch in as things keep arriving in S3.
Yeah.
Is this going to make that last query faster? The last query didn't have any where clause.
Yeah. This one definitely will make it faster. All right, we'll see. But the very first time I ran it, if I go to my DevTools, and DevTools is a way to check in all your indexes, right? So if I do a cat indices on it, it would have created a skipping index, which the first refresh is still happening, right? So it probably has not brought in all the metadata because there is no document yet, right? It's still in the process of bringing in stuff. So it's going to take some time to get going when the first time you create it because of all the work it has to do. Now, like, we can create a different acceleration pattern similar to that called the covering index, right? And the ultimate goal is once you have these in, your queries get faster, right? So in the interest of time,
Can you make the last query faster? Yeah.
Yeah. So I have the acceleration patterns created in a different domain, which we can probably use to quickly show you how we can speed things up.
Okay. Speed.
Because this one is still, let's quickly see.
This one's doing the indexing.
Yeah, it's doing the indexing. It's probably still running the jobs behind the scenes for us. So let's go back to query bench. And let me try to get the other.
I always get nervous when the person doing the demo says try.
Yeah. So you can see my dashboards, right? So this is the exact same setup, just something that I have so that if I check for those indexes, now you can see that it has brought in data for skipping and covering index, right? So there is acceleration that's happened. So if I'm about to run a query on that exact data.
There's the where clauses. All right, so the index is helped with the where clause because instead of reinforcing it, it should go faster. Oh, that was faster.
Yeah, there you go.
So, yeah.
You said try. I got nervous, but it worked out.
Yeah.
Now, last time I was promised a dashboard.
That's right. The coolest part of all this is you don't have to always go and create all these indexes for you, right? So what we have done is we have made it easier. So let's say it's VPC flow logs that we are going to do, right? So I can quickly find the integrations part. There you go. So there are integrations that are available where I can
go back. Yeah. All right. We got VPC, CloudFront, ELB, RDS. Oh, you got a lot. So it knows
brands.
how these things output. All right.
Yeah. So these are logs that we already know the schema. So we know, we can use certain patterns and get going, right? Ultimately, it's going to create all those acceleration patterns behind for you. It's understanding the schema. So let's try setting it up. So I'm going to just call it this. I'm going to use the data source. I'm going to call it Spark Flow. Let's give the checkpoints real quick.
You added a space or something there.
Yeah, and like
a leading space.
Live.
Nice. I think your one above had a leading space, or maybe they both do, because you're getting an error.
Oh, I am. Right. So.
Yeah. I think before the S3 at the left. Is that it?
There we go.
Yeah, there it is.
Yeah. So I can choose what kind of queries I want and just add integration, right? So
the dashboards.
Yeah. So what's now happening is behind the scenes, we have these the dashboard objects and visualizations that has been pre-created for VPC flow logs, right? So information that's relevant and something that you would need. So we have that being built, plus the acceleration patterns that we manually built for the VPC flow logs. This integration already takes care of that, right? So it's spinning up dashboard objects, it's creating those acceleration patterns, and it's validating your data in S3, doing all those checks while setting this up. The beauty about all this is for regular operational logs that we know, we made it super easy to just go set and take advantage of all these acceleration patterns that would now reduce a lot of these burden on you, and you are up and running with a dashboard that gives you answers right away.
Right. So all that stuff we were clicking on, like making the definition of the table, and it goes up and investigates to make sure our definition was right. All the index setup we were doing, all that stuff is going on here as the OpenSearch logo bounces.
That's right. Yeah.
Is the OpenSearch logo aware that the show ends in 3 minutes?
I'm sure it's pretty aware. So
will the materialized view that this integration build, will that need time to ingest that information into OpenSearch?
Yeah. Is that a question for me, Joshua?
Yeah, it's a question for you.
Yeah. So it's not using the existing MVs that I showed, right? So it's building new materialized view, which means it's also bringing in new data as we speak and building up these dashboards. So hopefully this data setup and
exciting ending.
Yeah, we are having a
This is a nail biter.
I know. You got 2 minutes, Jack. Yeah,
Maybe do we want to show up
the survey? There's a survey in the chat that maybe you want to wait 2 minutes, see if it all ends well. See if it can what you do in the next 90 seconds.
Yeah. You got an 8 minute going.
Or give Jack a 5 for doing it live for real.
Oh, there you go. Yay!
Show me the dashboard.
Right. So
you got 1 minute.
Yeah. So we got all these visualizations that we brought. I'm going to go click on a dashboard that
0
because it's 15 hours. I don't probably have data. Let me move it. There you go.
Oh.
There you go.
Ooh, buzzer shot.
Buzzer shot. We got a dashboard. That's a lot of data. No wonder it took.
Hey.
All right. It materialized that against S3 data that would normally be like hard to process. It materialized it to get a comprehensive view, all kinds of metrics, all kinds of graphs, everything like that. And with that, you pulled it off. I'll leave you off the hook. Your heart rate can go back down. and my
G-pointer buzzer.
I'll say, good job, Steph. I'll say that next week, at the same time, August 22nd, the next show, we're using transportable table spaces. And I did a quick Google of transportable table spaces, and I found that there's a lot of folding tables that go in your backyard. But I think that these transportable table spaces are something other than folding tables. Something nerdy. So that's next week's show. So thanks for everybody who's attending. Please fill out the survey. Thanks, Josh. Thanks, Jag. That was exciting. That was awesome. I appreciate it.
Yeah.
Thank you for having us.